One, two, three. We're going to talk about solving using the quadratic formula. The quadratic formula is listed on the right side of the screen. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's note that this only works when ax squared plus bx plus c equals 0. So if it doesn't have that form, or some sort of form where there's a quadratic in this case, and everything's on one side and the other side equals 0, then it doesn't work. The other thing that we have to take note here is that a must be non-zero. So our value for a must actually be something. If not, then this would be linear and we can't use the quadratic formula. Also note that the quadratic formula gives us some benefits. So if we see negative b over 2a in the quadratic formula, we know that that's the vertex x value. And we found that out from graphing a little bit ago. And then this other part, since x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, gives us the distance from the vertex, or I'm sorry, gives us the x-intercept. And we know that b squared, or negative b over 2a, gives us the vertex x value. That means the rest of this gives us the distance from the vertex to the x-intercept. I'll show you that in some examples in a little bit. So the benefits of the quadratic formula: it works anytime you have a quadratic equation, even when it's not factorable, so that's really beneficial. And if you know that ax squared plus bx plus c is equal to y, so if we think about it as a graph, you can see both the vertex and the horizontal distance to the solutions, as we just noted right here. When to use the quadratic formula: if factoring doesn't work and completing the square might be messy. Uh, as we can tell, it works every time. It's an algorithm, it's a formula, so it works. But the numbers can get pretty nasty sometimes, and so factoring oftentimes is the best bet. And we'll see that as we go through the exact same problems we did on the factoring worksheet. So if we look at the thing that we factored and got x equals negative 13 and x equals 3 as our solutions very, very fast, when we do the quadratic formula, there's a lot of plugging numbers in and just kind of cranking out some nasty solution stuff where we end up getting the exact same stuff. We end up getting negative 13 and 3. It just takes us a whole bunch more steps and a lot of multiplying. Like negative 4 times negative 39, we have to realize is 156. And a lot of times we're going to have to do that without a calculator. One thing to note, if we take a look at this right here, um, we know that negative 5 is this negative 10 over 2 situation. And so what that means is that is the vertex value, the x value of the vertex. If we take a look at this plus or minus 8 that we have here, that comes from plus or minus 16 over 2, which is this thing. So what that does is it tells us the horizontal distance from the vertex to the x-intercept is 8 in both the right and left directions. X squared plus 10x minus 39. We got negative 13 and 3 as our solutions with the quadratic formula. And remember that we said that the vertex x value was negative 5. And if we look at the horizontal distance in either direction of the vertex value, we end up traveling 8 in both directions. 4x squared minus 49 equals 0. Once again, we factored this really easily, but if we want to do the quadratic formula, we can see x equals negative b. Since b is 0 in this case, that becomes 0, plus or minus the square root of 0 squared minus 4 times negative 49 all over 2 times 4. So 4 times 4 times 49, there are two negatives in there, so it becomes a positive. We have the square root of 784, and the numbers get kind of nasty sometimes, but we end up getting the same answers we got when we factored. our values, our solutions were 3.5 and -3.5, and then the distance that we're traveling is 3.5 when we look at the quadratic formula, and the vertex value was 0. If we take a look at problem 3, A is 5, B is 30, and C is 0. So if we substitute these values into the quadratic formula, we get -30 plus or minus the square root of 30 squared minus 4 times 5 times 0, all over 2 times 5. And as we continue to simplify things, notice that 0 over here actually makes that pretty simple. So we just do 30 squared and get 900. The square root of 900 is 30. And we get 0 and -60 over 10, which ends up being 0 and -6. Once again, factoring probably gave us that a little bit quicker. One more time, we're going to note that this part, -30 over 10, is x equals -3. That's the vertex x value. And then this part, the distance from the vertex to the x-intercepts, is also plus or minus 3 in this case. So the distance here is plus or minus 3 in either direction. Problem 4, if we remember from factoring, we did not get any factoring solutions, but looking at the graph, there were some solutions. So we see 2x squared minus 21x plus 50 equals 0. A is 2, B is -21, and C is 50. So we do a little bit of work here. We get 21 plus or minus the square root of -21 squared minus 4 times 2 times 50, all over 2 times 2. And I did a little simplifying. Um, there's a red arrow, so that must mean something. B squared always ends up positive. That is super important. B squared always ends up positive. So even though B was negative, when we square -21, it ends up being positive. So we end up with 21 plus or minus the square root of 41 over 4. That would be our final answer. We could, if we wanted to, write that as x equals 21 over 4 plus or minus the square root of 41 over 4, and that's equivalent. We can't reduce the square root of 41 at all. I ended up getting solutions of 21 plus or minus root 41 all over 4. Notice that 21 fourths is the same thing as 5.25. And then if I actually take 21 plus or minus root 41 all over 4, I get approximately 3.649 and 6.851. 3x squared plus 20x plus 12. A, B, and C are listed. I write everything in the quadratic formula. I simplify some more with 400 and 144 becoming 256. Simplify some more. I end up with -6 or -2/3, which again, factoring would have been a whole lot easier in this case. If I want to make a note of this one more time, notice that -10/3 is going to be the x value of the vertex, and this plus or minus 8/3 is going to be the horizontal distance that we travel in both directions. 3x squared plus 20x plus 12 ends up giving me the solutions that were indicated. Finally, problem 6. I try to get everything on one side. A, B, and C are here. Do a little bit of writing everything in the quadratic formula. Once again, b squared will always be positive. That's something that's important. Notice here that 1 minus 100 is going to give me a negative on the inside of the square root. I'm going to get imaginary solutions, which we saw when we did the factoring video because the parabola did not intersect with -6. So I'm going to get an imaginary solution. When I simplify things, I get 1 plus or minus root -99 all over 10. I can take the I out of the radical and then note that root 99 is the same thing as 3 root 11. So that x equals 1 plus or minus 3i root 11 over 10 going to be my imaginary solutions here. Just a reminder that these two graphs don't intersect, so we are going to get imaginary solutions.